Hi, I'm Elle, and this is DV, and I'm going to attempt to explain DVC in a couple minutes using no code. Machine learning models are a special animal. They're not completely defined by the code that you use to specify them or by the data set that they're trained on. They're a reflection of both of those pieces. And so every possible way of changing our data set, changing the way we process our data set, and changing our code represents its own experiment. And a machine learning project as a whole is like a family of all of these different models. And so the complexity is huge. It's not complexity in like big O notation. I'm talking about the complexity of all of the possible models that we could have created from every version of our data set, all the different ways we tried transforming it, and all of the ways that we tried modeling it. The complication from this is that it becomes very difficult to log what we've already done, to reproduce what we've done, to share what we've done, and all around it makes machine learning difficult for none of the fun reasons that most of us get into it. So we need tools to help us deal with this complexity. And we have a couple constraints for our solution. We want it to be extremely flexible. Ideally, it would work with any programming language, any machine learning framework, whatever. And we want it to be pretty straightforward to learn based on all the tools that people are already using to manage software projects, because we want to keep the cognitive load light. The underlying philosophy of DVC is to use a tool that's really popular and really successful for managing the complexity of software development projects, which is Git version control, and extend it so that we can use it for data science and machine learning. So I'm going to attempt to demonstrate why this requires a tool using only some objects from around my house. I've got these index cards, which can represent the files in my project. So maybe I've got a script to pull the data from storage, a script to clean it, a script to process and featureize it, and a script to model it. So these are lightweight, right? They're easy. And I want to use Git to take a snapshot of my project at any point in time. And so Git commits are a snapshot. And so Git is built for lightweight files, right? It handles little files. So we can take a snapshot, we can just make a copy of everything in our project at some state in time, and then we can have a bunch of these commits, and that means we can always revert back to, oh, where was I right then? What did it look like? Easy, great. Works for everyone, except when you have really big files. So in data science, your data sets and your models are big, right? They're not index cards anymore. They're more like the fourth book in the Twilight saga. This came with my house. Books 1 through 3 are not here. I only have this book. I don't know. Anyway, it's not going to fit in my Git repository. So what we can do is take another very lightweight file, and I can write down on this file where I'm going to store this book. Like I could write on this, okay, I'm going to store it on the third shelf of my bookshelf, second from the left. And then I can put this in my Git commit, and boom, now I've got a way to access my data set, even though I'm not trying to fit this data set into my Git repository. So that's the gist of DVC. Lots of people engineer their own ways to do this. You know, it's a pretty popular approach, but the point of the DVC open source project is to really polish and standardize this so that people don't have to engineer this themselves every time they want to be Git versioning and keeping track of their big files like models and data sets. DVC is more than just that one trick. So kind of starting from the idea of using meta files to version data sets and models, plus the cultural practices around using Git, we've built some other features that tend to be pretty popular. Pipelines are a cool way to tie together data sets to scripts to models and version that as a pipeline. Another cool thing is metrics and plots. So DVC metrics allow you to compare model performance across commits. And recently we added plots so that you can visualize how a model has changed across commits. Another value is continuous integration. So continuous integration is a really foundational idea in DevOps for automating frequent tests of your project. And so with DVC, you can use continuous integration systems to automate testing of your machine learning models. So that's kind of the scope of DVC. There's an open source community, so lots of active development. There's pretty much always something being made. So I definitely recommend checking out the project repository. That was my 5-minute explanation. How did I do? Let me know in the comments. Any questions, we'll try to answer them. And thank you for watching.